Hello, apparently we're live, but I don't have my intro. Oh, I know. Look at that. Now. Yay, so I ran the intro. For some reason I blocked it in the last live stream. Oh well, hello, welcome everybody. How are you? Last time we did all the algorithm scripting on the freeCodeCamp curriculum. It was pretty fun. It went way faster than I initially thought, but we also had some fun. I messed up a couple of problems, but eventually we finished. So that's what is important, right? Alrighty, let's see if everything was working, if you can hear me well. OBS says that you can, so I'll trust it. Today we're going to look over object-oriented programming in JavaScript, which is an interesting topic, not that easy, but it's good to know. Hello Thanos, Aman, Gulsham, Ankit, Sahash. Guys, you have so hard names for me to pronounce. Thank you, Ankit. I'm fine-ish somehow. I want to go over OOP and functional programming today, hopefully. This will be in the next live stream, so that we can focus on this bad boy probably tomorrow. For those of you who are watching the recording, as always, you can find all of the live streams recorded in a playlist, which is in the description. Make sure you check them out in case you missed something or you want to go over what we did so far. Alrighty, I think we can get into OOP. Let's see what this says. At its core, software development solves a problem or achieves a result with computation. The software development process first defines a problem, then presents a solution. Object-oriented programming is one of several major approaches to the software development process. Alright. As its name implies, object-oriented programming organizes code into object definitions. These are sometimes called classes, and they group together data with related behavior. The data is an object's attributes, and the behavior of functions are methods. Okay. The object structures makes it flexible within a program. Objects can transfer information by calling and passing data to another object's methods. And also new classes can receive or inherit, which is pretty nice, inheritance, all the features from a base or parent class. This helps to reduce repeated code, which we want to do usually. So we don't want to repeat our code, we want to make it as dry as possible. Dry stands for don't repeat yourself. Your choice of programming approach depends on a few factors. These include the type of problem, as well as how you want to structure your data and algorithms. This section covers object-oriented programming principles in JavaScript. Alrighty. Let's see, create a basic JavaScript object. Okay. We created objects before. Think about things people see every day: cars, shops, birds. These are all objects. Tangible things people can observe and interact with. What are some qualities of these objects? A car has wheels, shops has and sells items, and birds has wings, among other things. These qualities or properties define what makes up an object. Note that similar objects share the same properties, but may have different values for those properties. For example, all cars have wheels, but not all cars have the same number of wheels, right? So we have cars with 3 wheels, with 4, with 6, with 8, and so on. I guess those are trucks, right? Well, it's some sort of a car, a bigger car. Maybe a truck can inherit from a car, and oh well. I think you'll get the point. Objects in JavaScript are used to model real-world objects, giving them properties and behavior just like their real-world counterparts. Here's an example using these concepts to create a duck object. Look at that, we have a duck with a name of Affleck. And it has number of legs too. Okay, our duck has legs. Apparently it's a healthy duck. Alright, let's get into it. Create a dog object with name and normal legs. Okay, name. What name should we give our dog? Chat, let me know if you prefer some name. And number of legs. Let's make it 4. Regular dog. Nothing special. A name. Maybe, I don't know. Blackie? I have a cat called Black, so why not a dog Blackie? Alright, good. Cozy. Okay, let's change it to cozy. Awesome. Next challenge. Use dot notation to access properties of an object. Okay, we learned about this, right? We can access properties inside of an object by using the dot notation. Like this. If you want the name, you can say duck.name. Print both properties of the dog object to the console. Alright, console.log, which is the method we can use to print to the console. And we can say dog.name. Also console.log dog.numlegs. And we have Spot with 4 legs. They changed our cozy dog. Alrighty. Create a method on an object. Okay, we saw this previously, but we never created a function a method on an object. Okay, objects can have a special type of property called a method. Methods are properties that are functions. This adds different behavior to an object. Here is the duck example with a method. You can see that to the sayName property we assign the function, which will return the name of this duck is duck.name. Okay. Using the dog object, give it a method called sayLegs. Okay, sayLegs. This method should return the sentence, this dog has 4 legs. Now we can do a function here and just return this dog has 4 legs, which is valid. Let's see, console.log this. Okay, it says this dog has 4 legs, but we haven't used the numLegs property. Maybe this is what, apparently this is not what they want necessarily, but let's do it anyway. So instead of 4, we can add a ++ here and say dog.numLegs. So now it will say the same, this dog has 4 legs, but the cool part is that now unfortunately the dog loses a leg, it will update, and the sayLegs will say exactly how many legs the dog has. Alright. Okay. Make code more reusable with the this keyword. This keyword is very interesting, and you most likely want to understand it. Hello Edson, welcome to the live stream. So let's see what they say about the this keyword. The last challenge introduced a method to the duck object. It uses duck.name.notation to access the value of the name property within the return statement. We had say name, a function, and then we use a duck.name. While this is a valid way to access the object's property, there is a pitfall here. If the variable name changes, any code referencing the object name would need to be updated as well. In a short object definition, it isn't a problem. In a short object definition, this isn't a problem. But if an object has many references to its property, there is a greater chance for error. A way to avoid these issues is with the this keyword. You can see here that they changed the duck to this, and this keyword refers to the object in which is called. Keep this in mind. This is a deep topic, and the above example is only one way to use it. In the current context, this refers to the object that the method is associated with, duck. So we have the method sayName, which is associated with the duck object. So this, in this case, refers to the duck. If the object's name is changed to Mallard, it is not necessary to find all the references to duck in the code. It makes the code reusable and easier to read. Alrighty. Modify the dog say legs method to remove any reference to dog. Use the duck example for guidance. Okay, so we used dog inside here. We can change this to this. And now it should be fine. Alright, let's see. Yep, it works. Define a constructor function. Constructors are functions that create new objects. They define properties and behaviors that will belong to the new object. Think of them as a blueprint. Think of them as a blueprint for the creation of new objects. Here's an example of a constructor. We have a function bird, and you can see how it uses the this keyword. And in this case, the this keyword will refer to the bird object. Well, functions are objects also, right? I think I'm not wrong in my deep knowledge of JavaScript. Okay, let's see. This constructor defines a bird object. See? Yeah, so it's an object. It might be weird, but you'll get the hang of it with some practice. So this constructor defines a bird object with properties name, color, and numLegs set to, well, the values. Constructors follow a few conventions. Constructors are defined with a capitalized name to distinguish them from other functions that are not constructors. Constructors use the keyword this to set property of the object they will create. Inside the constructor, this refers to the new object it will create. Okay. Constructors define properties and behaviors instead of returning a value as other functions might. Okay, one more time. Constructors define properties and behaviors instead of returning a value as other functions might. Okay, we'll see probably in the next one why we would want to do this kind of functions. Hello Ivan, welcome to the live stream. Okay, let's see. Create a constructor function. This is how we create a constructor, Doug. Well, in ES6 we have a better way to create constructors, but for now we're going to use a function keyword. So we have a constructor Doug with 3 properties. Okay, this name should be a string, check. Then this color should be purple, a purple Doug, and this numLegs should be 4. So now we have the Doug constructor function with 3 properties: name, color, and numLegs. Let's see what we do with them. Use a constructor to create objects. Okay, give me a few seconds to drink some water. Alrighty, I'm back. Here is the bird constructor from previous challenge. So we can did the bird constructor, and look at this. We have something new here. Well, the new keyword is new to us. And what we did here, well, actually what they did is they created a bluebird variable and equal to a new bird. Let's see what this does. Notice that the new operator is used when calling a constructor. This tells JavaScript to create a new instance of bird called bluebird. Within the new operator, this inside the constructor would not point to the newly created object, giving unexpected results. Now bluebird has all the properties defined inside the bird constructor. You can see we can access it by saying bluebird.name, color, and numLegs. Just like any other object, its properties can be accessed and modified. Alright, so basically we created some kind of object. But why would we want to do that? Okay, let's do the challenge and probably we'll learn this in the next one. Second, I got a message. Okay, so use the dog constructor from the last lesson to create a new instance of a dog. Assign it to a variable hound. Okay, so const hound, because we don't want to change it for now, will be a new dog. We can also do const puppy, which will be a new dog. But I guess we'll learn about this in the next one. So let's go to the next challenge. Extend constructors to receive arguments. Okay, this seems logical, sort of. The bird and dog constructors from last challenge worked well. However, notice that all birds that are created with the bird constructor are automatically named Albert. Yeah, and in our case, our dogs were named the same. We haven't tested it, but yeah, trust me. Yeah, the birds are named Albert, are blue in color, and have 2 legs, because that's what we did in the constructor. We set the color, the name, and the legs to be the same. But what if we want the birds with different values for name and color? It's possible to change the properties for each bird manually, but that will be a lot of work. You can see here we can declare a bird, and then we can change their name and color. Suppose you were writing a program to keep track of hundreds or even thousands of different birds in an aviary. It will take a lot of time to create all the birds, then change the properties to different values for every one. To more easily create different bird objects, you can assign your bird constructor to accept parameters. And now we can start to see what powerful JavaScript is with what the OOP, how powerful can be. You can see here we passed in name and color, and we assign them to this .name and this .color. So now when we initiate a bird, we can pass in the constructor whatever name and color we want, and then that bird will have the corresponding name and color. Okay, yeah, look, as you can see here, we create the cardinal and we say new bird, Bruce and red. Keep in mind that these should be in the same order we have here. Alright, this gives a new instance of bird with name and color property set to. Okay. Then if we want to access them, we retrieve the corresponding name, color and legs. Okay. The constructor is more flexible. It's now possible to define the properties for each bird at the time it is created, which is one way that JavaScript constructors are so useful. They group objects together based on shared characteristics and behavior and define a blueprint that automates their creation. Create another dog constructor. This time set it up to take the parameters name and color. And have property numLegs fixed to 4. Then create a new dog, save the variable. Okay, so we want this .name to be the name from the parameters. Then this .color, and we want all the dogs to have this numLegs to be 4. This is something we want for all of the dogs. Next, you want to create a new dog, terrier, and set it to be a new dog with the name of, I guess, terrier and color blue. Now if we console.log terrier, like this, you can see that it has the name terrier, the color blue, and 4 legs. We can set another dog, puppy, with the name, new dog with the name of puppy, and it should be purple because I have funny colorful puppies, dogs. Okay, and now you can see that our puppy has a different name and a different color, but the same number of legs. Alright. Verify an object's constructor with instance of. Okay, so basically we have this keyword and we can see if an object, if a property that we created is an instance of the constructor. Let's see, I get confused with the naming, so let's read it. Anytime a constructor function creates a new object, the object is said to be an instance of its constructor. Okay, so we have the crow object, which is an instance of the bird constructor. JavaScript gives a convenient way to verify this with the instance of operator. This allows us to compare an object to a constructor, returning true or false based on whether or not that object was created with the constructor. Here's an example. We have the bird, and then we create a new bird, crow, and we test to see if it is instance of bird. If an object is created without using the constructor, instance of will verify that it is not an instance of a constructor. Okay, you can see here we created an object, but we created on the fly, and it's not an instance of bird because we haven't used the new bird constructor to create it. Okay, create a new instance of house constructor, calling it my house. My house will be a new house. number of bedrooms, 1000. Then use the instance of to verify that it is an instance of a house. So console.log my house instance of house. Is it? Yes. But if we do const your house, which will have number of bedrooms 1, then if we test this, let's create another console.log your house instance of house. No, because we created on the fly. All right, let's give you 1001 bedrooms. Good. Next, understand own properties. In the following example, the bird constructor defines two properties, name and numLegs. Name and numLegs are called own properties because they are defined directly in the instance object, on the instance object. That means that duck and canary each has its own separate copy of these properties. In fact, every instance of bird will have its own copy of these properties. The following code adds all the own properties of duck to the array own props. Let's see, so we have an array, we go over all the properties in duck. If duck has own property, then we push it to the own props. So we can see name and numLegs. Alright. Add the own properties of canary to the array own props. I guess we can do this. And we can change this here. And now if we console log own props, we should have name and numLegs, because this is an instance of bird which has this own property. Alright. Use prototype properties to reduce duplicate code. Since numLegs will probably have the same value for all instances of bird, you essentially have a duplicated variable numLegs inside each bird instance. This may not be an issue where there are only 2 instances, but imagine if there are millions of instances. That will be a lot of duplicated variables. A better way is to use bird's prototype. Properties in the prototype are shared among all instances of bird. There's how to add numLegs to the bird prototype. Oh, really? I never really knew this. So if we set a property with prototype, it will be shared, but it won't be duplicated. Interesting. Alright, see, after years of working with JavaScript and you learn new things. And I've looked over prototype and all this, but I never understood why would you do prototype if you can do it inside of the constructor. Alright, thank you freeCodeCamp. Now I understand. Yeah, you can see that they added the numLegs on the prototype, and now the duck and canary have the numLegs. Since all instances automatically have the properties on the prototype, think of a prototype as a recipe for creating objects. Note that the prototype for duck and canary is part of the bird constructor as bird.prototype. Nearly every object in JavaScript has a prototype property, which is part of the constructor function that created it. Alright, interesting. Let's add a prototype. On the prototype, the property numLegs for the dog. Dog.prototype, dog prototype that numLegs and 4. Now if we console.log, we get console. We get name and Snoopy. Prototype. Legs, and we created a new dog. Interesting, so it doesn't have it, but can we access it? Legs. Oops. Oh, that's nice. So we can't see it here if we console the object, but it does have it. Alright, that's weird. I wonder if in console it will show. I mean, probably not weird, but usual, and I didn't know. Clean. Run this again. Yeah, dog name Snoopy. But if you console the dog, the function with this name and dog.prototype, the prototype has the num of legs. Interesting. Alright. Let's see what new are we learning. In this challenge, iterate over all properties. You have now seen two kinds of property, own property and prototype properties. Own properties are defined directly on the object instance itself, and prototype properties are defined on the prototype. Okay, so these are own properties, and this is a prototype property. Here is how you add duck's own property to the array own props and prototype property to the array property props. Oh, I see now. So we have this for in loop which goes over all the properties, but apparently has own property only. Well, it's logical that it only returns the own properties, and then we are left with some properties which are not there, but it will still be in the loop. Okay, I see. Yes, so basically when I learned about the for in loop, I was told to use this if has own property, but I was like, oh well, why would you do that, because it will go over all the properties anyway. But apparently maybe we don't want to go over the prototype properties, only over the own property, right? Okay, nice. Add all the own properties to Beagle, blah blah blah. Okay, so pretty much this, and instead of duck we have this. I want to see all the properties here. Console.log property. Name and numlegs. Okay. So if we have here this .color should be color, and we get it from the constructor, and then we declare it here, whatever red, it will appear. Color will appear here. Let's also console.log the two arrays, own props and prototype props. Name and color and numlegs is in the prototype props. And we can also add something common to all dogs. What? Eyes. Number of eyes. 2. Okay, so you can see the difference. We have two arrays, the own properties and the prototype property. Okay, good to know. Thank you, freeCodeCamp. Understand the constructor property. Okay. There is a special constructor property located on the object instances duck and beagle that were created in the previous challenge. So duck.constructor, beagle.constructor, which will be the same as the dog or bird constructors. Okay, seems logical. Note that the constructor property is a reference to the constructor function that created the instance. The advantage of the constructor property is that it's possible to check for this property to find out what kind of object it is. Here's an example of how this could be used. Well, isn't it the same like using instance of? Yeah, since the constructor property can be overwritten, which will be covered in the next two challenges, it's genuinely better to use the instance of method to check the type of an object. Alright, give me a couple of seconds, I'll be right back. Okay, I'm back. Sorry for the delay. Let's see. We had to write a join dog fraternity function that takes a candidate parameter and using the constructor property returns through, well, basically this. Oh, there is already here. So we can only copy this and change the bird to dog. Which, oh well, because here they use return true else return false. But what if we just do this? Return the check between the two. It is in one line of code and it's much better. Oh, let's call it console.log join dog fraternity with a candidate. Yes, we should create a candidate. Const Dougie, new dog Dougie. Run out of dog names. So with the Dougie, yeah, it will return true. Good. Next, we're close to 50%. Change the prototype to a new object. Ooh. Up until now, you have been adding properties to the prototype individually. This becomes tedious after more than a few properties. Okay, you can see here we can add functions to the properties. A more efficient way is to set the property to a new object that already contains the properties. This way the properties are all added at once. Okay, so prototype will be a new object with all of these properties: the numlegs, the method eat, the describe method. Okay, add the property numlegs and the two methods eat and describe to the prototype of dog. Okay, here we go. By setting the prototype to a new object. So we have dog prototype to a new object. We have the legs for eat num num num. Good for me in describe. My name is this.name. You can see that the this keyword also works because this prototype is referring to the dog constructor. So it will know which what name to pick. 50%, great. Yeah, I know that this topic might be a little boring because it's a little higher level, but it's nice to know it. You might use it especially when you want to create like bigger projects with a lot of properties, objects, a lot of objects with properties and copies of that object and all sorts of things moving around the screen. So although it might be a little boring, keep going and try to understand it as much as possible. Hopefully we'll make some examples later in the challenges, which will be like an overview of what you would do in a real life situation. Well, this is actually, but well, you won't create probably dogs or something. Okay. Remember to set the constructor property when changing the prototype. This is one crucial side effect of manually setting the prototype to a new object. It erases the constructor completely. Not completely, that's not the completely, that's property. So it erases the constructor property. This property can be used to check which constructor function created the instance, but since the property has been overwritten, it now gives false results. Okay, you can see here that the duck constructor, after changing the prototype, is not bird anymore, but it is object, because we basically gave it a new object. All objects inherit from object.prototype. Keep this in mind. All objects inherit from object.prototype. But you can see that that instance of bird still works. So that works, right? To fix this, whenever a property is manually set to a new object, remember to define the constructor property. So we can tell the constructor, even if we assign to a new object, that the constructor is bird. We define it manually. Define the constructor property of dog. Constructor will be dog. Interesting, it has another color. Okay, not bug, dog. Understand where an object's prototype came from. Just like people inherit genes from their parents, an object inherits its prototype directly from the constructor function that created it. For example, here the bird constructor creates the duck object. Duck inherits prototype from bird constructor function. You can show this relationship with the is property of. Okay. I didn't know about is property of. Bird prototype is property of. Okay. Use is property of to check prototype of big dog. Prototype is prototype of eagle. Also, these type of questions, OOP, might come up if you go to an interview. So this is why you would like to know it. Understand the property chain. All objects in JavaScript, with a few exceptions, have a prototype. Also, an object's prototype itself is an object. Type of bird prototype, you can see it's an object. Because a prototype is an object, a prototype can have its own prototype. So a prototype has a prototype. In this case, the prototype of bird.prototype is object.prototype. So they go up in chain. Object prototype is prototype of bird.prototype, and it will return true. How is this useful? You may recall the hasOn property method from a previous challenge. Okay, the hasOn property method is defined in object.prototype, which can be accessed by bird.prototype, which can then be accessed by duck. So they go down from object to bird to duck. This is an example of the prototype chain. In this prototype chain, bird is the supertype for duck, while duck is the subtype. Object is the supertype for both the bird and duck. Object is a supertype for all objects in JavaScript. Therefore, any object can use the hasOnProperty method. Okay, so did you understand? We have the hasOnProperty method on objects because they are subtypes of the object. Hope that makes sense. Modify the code to show the correct prototype chain. Is prototype of object. Object prototype is prototype of duck prototype. The thing with these freeCodeCamp challenges is that, well, you kind of have what you have to do in the left, so you can just copy paste it. There are some of them which you have to create from scratch. Those are good because you have to put your mind to work. But these ones are not the best because you can just copy it and then forget about ever doing it. There's a principle in programming called don't repeat yourself, or DRY. The reason repeated code is a problem is because any change requires fixing code in multiple places. This usually means more work for programmers and more room for errors. Notice in the example below that the describe method is shared by bird and dog. Describe. Okay. The describe method is repeated in two places. The code can be edited to follow the DRY principle by creating a supertype or parent called animal. Yeah, so what they mean here is that, for example, you want to change the describe function to say not my name is, but I don't know, my name was. So let's say you want to add a dot at the end, but you'll have to go here and add the dot and here and add the dot. So that will be double the amount of work. But in this case, we create an animal constructor, and then on the prototype, we describe the function. And then we can point the bird prototype. Okay, let's see. Since animal includes the describe method, you can remove it from bird and dog. Okay, so they removed it. But how? Let's see. How are we linking it? Okay, so they don't show us this time. Let's see. The it method is repeated in both cat and beer, whatever. Edit the code snippet. Code in spirit of DRY by moving the it method to the animal supertype. Okay, we moved it, but we haven't connected the animal with the cat and beer. Or how do you pronounce that? Okay, I guess we'll do it in the next one. Inherit behaviors. Okay, yeah. In previous challenge, you created a supertype called animal that defines behavior shared by all elements, the it. This is the next challenge. This and next challenge will cover how to reuse animals method inside bird and dog without defining them again. It uses a technique called inheritance. This challenge covers the first step, make an instance of the supertype or parent. You already know one way to create an instance of animal using the new operator. So we create an animal with the new animal operator. There are some disadvantages when using this syntax for inheritance, which are too complex for the scope of this challenge. Instead, here's an alternative approach without those disadvantages. Let animal object.create animal.prototype. I never use this. So let's see. It creates a new object and sets object as the new object's prototype. Recall the prototype is like the receipt for creating an object. By setting the prototype of animal to be animal's prototype, you are effectively gaining the animal instance the same receipt as any other instance of animal. I didn't quite get that. So by setting the prototype of animal to animal's prototype, you are effectively giving the animal instance the same receipt. What we set here, it has the eat. Why? Yeah, I don't understand now. Probably will in the next one. Use create object that create to make two instances of animal. Let me copy this and this. Yeah, so num. Set the child's prototype to an instance of the parent. In the previous challenge, you saw the first step for inheriting behavior from the supertype or parent animal, making a new instance of animal. This challenge covers the next step. Set the prototype of the subtype or child, in this case bird, to be an instance of animal. So bird.prototype will be object create animal prototype. Why wouldn't it work with new animal? Remember that the prototype is like the receipt for creating an object. In a way, the receipt for bird now includes all the key ingredients for animal. Let duck is new bird, Donald. Duck.eat, num. Okay. Duck inherits all the animal properties, including the eat method. Modify the code so the instance of duck inherits for animal. Alright, this is the time we can test. And this is what I do when I don't understand something. I'll change it the way and see how it works. So we need to make the dog prototype to point to a new animal, right? New animal. Oh, so for animal.prototype. That's in the previous one. They said we shouldn't do that. New animal. Oh, yeah, so new animal is the same as saying object create new animal. Animal prototype. Okay. So let's go back here and set dog.prototype to be new animal. Yeah, it works. So why do we need to do this object.create? We can just point the prototype of dog to be a new animal, so it will inherit. And you can see now that the beagle, which is a dog, has the eat function, which prints num. So yeah, I have no idea, and probably you don't also. If you do, let me know. Reset an inherited constructor property. When an object inherits its property from another object, it also inherits the supertype's constructor property. Here's an example. We have bird, we set the bird prototype to an animal, and the duck constructor will be function animal. Oh, okay. But duck and all instances of bird should show that they were constructed by bird and not animal. To do so, you can manually set bird's constructor property to the bird object. So after you do bird.prototype is new animal, you have to say bird prototype.constructor to be bird. Okay. It's just me, but or this looks weird. Fix the code so duck constructor and beagle constructor return their respective constructors. So I guess we can say bird this, and then again, but we change this to dog. Let's see, console.log. Hello, bloodling. Constructor prototype constructor equals to bird. Well, constructor, yeah, bird. If we don't do this, it's not bird. No, it's animal. Okay, I see why you need to do this. I don't see why they don't do it by default, sort of. Add methods after inheritance. A constructor function that inherits its prototype object from a supertype constructor function can still have its own methods, in addition to inherited methods. For example, oops, sorry, dropped my pen. For example, bird is a constructor that inherits its prototype from animal. So we have animal, that's the eat function, method, whatever. We have the bird, and then we set the bird to be a new animal, and we set back the constructor of the bird to be bird. In addition to what is inherited from animal, you want to add behavior that is unique to bird objects. Here, bird will get a fly function. Functions are added to bird's prototype the same way as the constructor function. Okay, new instances of bird will have both eat and fly. So this is kind of what you want to do if you inherit from a parent. So let's say we have the animal, right, which has the eat function, and then you create a dog and a bird, which both inherit the eat function. But if you just do that, just inherit the eat function, then why would you create another object, another constructor function like dog? You have to have something specific for your dog, and you want to have the eat function, which is inherited for all the animals, right? Alrighty. Okay. Duck, new bird, and eats and fly. Add all necessary code so the dog object inherits from animal. Let's see. Dog.prototype will be new animal, right? Okay, then dog.prototype.constructor will be dog. So we're resetting the constructor. And we also want to have bark on dog.prototype. So dot.prototype dot fly, not fly, dot bark will be a function which will print woof. Woof. The lazy dog, woof. So we can see that the dog can eat now, num num num, from the animal, because it inherited from the animal the eat function, and it can also bark because we added to the prototype. And we couldn't do this before inheriting because it will be deleted when we're setting the prototype here. So we need to do it after. Although I'm not sure if we need this. Do we? Not that necessarily, but who knows. Oh, the constructor for beagle should be set to dog. Constructor for beagle we set to dog, but it is. Property constructor dog. What you're doing? What's wrong? Add all the necessary code so it inherits an animal, and the dog's prototype constructor is set to dog. Constructor Okay, I missed the S here. There. All right. Almost done, almost done. Hang in there. Override inherited methods. In previous lessons, you learned that an object can inherit its behavior from another object by referencing its prototype object. Child object.prototype will be object.create, blah blah blah. Don't know why they do this. We just do new parent object. Then the child object receives its own methods by changing them onto its prototype. Child object prototype, and we create our methods. It's possible to override an inherited method. It's done the same way by adding a method to child object prototype. Okay, this is kind of redundant, so we wouldn't do exactly this in a situation, but it's good to know if in case you want to do something similar. You can see here that the animal has the eat function method, and then we want to override it. The bird, instead of saying num num num, it will say peck peck peck. But well, in a real case scenario, if the bird only inherits the animal because of the eat function and then it overrides it, well, basically you don't have to inherit them from the animal, right? You might overwrite one of the properties. So for example, the animal has eat and walk and jump and poop, but you want to override birds.eat function method. Keep confusing them. So a method is a property which has set the value to function, right? It's inside an object. Okay, confusing terms, but hopefully you know what I mean. If you have an instance of let dog is new bird, you call duck.eat, this is how JavaScript looks for the method on duck's property chain. Duck, is eat defined here? No. Bird, is it defined here? Yes. Execute it and stop searching. Animal, it is also defined, but JavaScript stops searching before reaching this level. Object, JavaScript stops searching before reaching this level. Okay, so you can see that from the bird, we got duck, we got bird, animal, and object. Override the fly method for penguin so that it returns alas, this is flightless. Penguin prototype fly will be function return so without this the bird will say I am flying, the penguin, and if we override it we'll say alas, this is a flightless bird. They can still jump probably, right? Use a mixin to add common behavior between unrelated objects. Okay, this sounds interesting. As you have seen, behavior is shared through inheritance. However, there are cases when inheritance is not the best solution. Inheritance does not work well for unrelated objects like bird and airplane. Why? Bird and airplane are both flying. Why can't they share a common fly method? Yeah, they can both fly, but a bird is not a type of airplane, and vice versa. Well, a bird can be a type of airplane if it's a mechanical bird, right? Sort of. Okay, I'm kidding. For unrelated objects, it's better to use mixins. A mixin allows other objects to use a collection of functions. Oh, I never heard of mixins in JavaScript. Let fly mixin be a function which takes an object, and then on that object it will assign the fly property to a function. Interesting. The fly mixin takes any object and gives it the fly method. So bird and plane, they are objects and don't have a specific don't have the fly method, but we can add it by saying fly mixin. Here bird and plane are passed into fly mixin, which then assigns the fly function to each object. Now bird and plane can both fly. Nice. Note how the mixin allows for the same fly method to be reused by unrelated objects, bird and plane. Create a mixin named glide mixin that finds a method called glide. Then use the glide mixin to give both bird and boat the ability to glide. Hello again, we were having a good chat in this. Hi, welcome to the live stream. Discord, what were you talking about? Now or before? Okay. Oh. Yeah. Maybe you can get it up. Alright. Let's return to our FreeCodeCamp curriculum challenge. We need to create a glide mixin, so let's just copy this, change it to glide, add this to glide, and it will say something. What's the sound that you're gliding? Glide. Alright. Then we can call this glide mixin and pass in the bird and the boat. Voila! Use closure to protect properties within an object from being modified externally. Hang in there guys, we only have a couple more. In the previous challenge, bird has a public property name. It is considered public because it can be accessed and changed outside the bird's definition, bird.name. Therefore, any part of your code can easily change the name of bird to any value. Think about things like passwords and bank accounts being easily changeable by any parts of your code base. That could cause a lot of issues. The simplest way to make this public property private is by creating a variable within the constructor function. This changes the scope of that variable to be within the constructor functions versus available globally. This way, the variable can only be accessed and changed by methods also within the constructor function. Oh, look at that. This is nice. So we declare a variable here, not with this, but a separate variable, and we give it the value of 10. And we can only access that variable's value by calling this function. Alright, interesting. Here getHatchedEggCount is a privileged method because it has access to the private variable hatched egg. This is possible because hatched egg is declared in the same context as getHatchedEggCount. In JavaScript, the function always has access to the context in which it was created. This is called closure. Change how weight is declared in the bird function so it's a private variable. Then create the method getWeight that returns the weight. Okay, so instead of this.weight, we want a letWeight to be 15, private variable, and then we want this.getWeight to be a function which will return the weight. Okay. Nice. Understand the immediately invoked function expressions. or called otherwise ifs. A common pattern in JavaScript is to execute a function as soon as it's declared. You can see here we have a function and we wrap it inside parentheses, and then we add the ending parentheses so we can call it immediately. This is an anonymous function expressed that executes right away. Outputs chirp chirp, whatever, immediately. Note that the function has no name and it's not stored in a variable. The two parentheses at the end of the function expression cause it to be immediately executed or invoked. This pattern is known as an immediately invoked function expression, or IFI. We write the function makeNest and remove its call, so instead is an oh boy. So instead it's an anonymous immediately invoked function. Why can't I just say IFI? What is the use case of IFI? Asked Joy. Okay, I'll tell you in a second. So instead of this, let's remove the name, remove this, wrap this inside parentheses, and call it like this. One of the use cases of IFI is when you want, like for example, jQuery is an IFI, I think. Don't want to be mistaken though, but basically when we write it, I remember when I write jQuery, you have the document already which was wrapped inside an IFI. So basically you call this right away when it's declared. And also you want to have its own context. So inside here you might have for example a constant being Florin set, or whatever name being set to Florin, but you don't want here to have access to it. Console.log name. Let me do this. Interesting that we don't get an error or anything. Empty string. Let's make it blah blah. Okay, blah blah is not defined, but probably name is defined somewhere. Okay, and here we can say console.log blah blah, which will know that is Florin, but here it won't know. And this happens if, for example, as I said, there was name, so name here. You can see that the name is Florin inside, but outside, well, is something else. I don't know what. Because we have an empty string, they probably have somewhere the program of freeCodeCamp platform variable name. Interesting. Let's say cat. Do we have cat? No. But inside here we might want a cat. So we run this, and then we can't access the cat inside. And you can have another IFI which has another cat. Now it could be Joy. Is not a function. What did I do? Type immediate value. Immediate value is not a function. It's console.log something here. Okay. So they apparently didn't like the fact that we have, we had parentheses and then parentheses again. So we might want to add a semicolon here. So you can see that we have a cat property inside this IFI and also cat property inside this IFI, but we don't have an issue. We can also have a const, here outside, as you can see, as you saw, we don't have a cat. But we can create a cat if you want. Cat will be, I don't know, come on. So we have 3 cats and they don't collide with each other. So basically creating a separate environment, or I bet there is a prettier word to describe this. I just forgot, but that's pretty much it. For example, libraries usually, I think they usually wrapped inside an IFI, because a library, let's say you work with two physics library, and they both might have a constant of gravity, right? If you import all of the two libraries, maybe because one of the library has a better way to handle collisions, and the other one has a better way to handle, I don't know, physics. That's, well, you know, so you want the both of them, but you don't want them to collide. So you wrap them inside an IFI, and then you call them, and they each do their job. Alright, and the last one. I hope this answered your question, Joy. That was a good question. Not sure if the answer was the best, but hopefully it was good enough. Use an IFI to create a module. Alright, so I basically explained that much, but look at that. We have here an IFI is often used to group related functionality into a single object or module. For example, an earlier challenge defined two mixins. We can group these mixins into a module as follows. We have a module and we have all the code. The two parentheses cause the function to be immediately invoked. Note that you have an IFI that returns an object, motion module. Okay, where? Oh, return. This returned object contains all the mixin's behavior as properties of the object. The advantage of the module pattern is that all of the motion behaviors can be packaged into a single object that can then be used by other parts of the code. Here's an example using it. Motion module glide mixin duck. So yeah, we wrapped this code inside an IFI, and then we return the glide and fly mixin. Although this is weird, why would we wrap inside the name? So that we have this, or and this is weird for sort of, I don't know. Create a module named fun module to wrap the two mixins. Fun module should return an object. Okay, so let's do what they did here. Let fun module will be an IFI function, and we call it, and oops, and inside here we want to return object with this equal will now be. So I basically, here we need comma. I basically converted what we had here to what we have here. And we are done. Alrighty. If you have, hopefully you don't, but if you have questions on this topic, let me know in the live chat or in the comments. If I don't know the answer now, I'm going to research and find the answer. OOP is nice. I just used it today to make a game, sort of. So it's nice because you're packaging your objects which have their own unique properties, and well, I guess I could show you my game which was built in a OOP method, sort of. I wanted to release this game, but it's not yet perfect, so let me show you what it does. Hopefully it works now. Yeah, it works harder than I'm in a live stream. So basically you had this cube, and by clicking the mouse you could change the gravity, and also it will glide sort of these boxes. Okay, you can see now. I'm going to stop this because for some reason works hard, not sure what I did. And you can see I have 3 JS files, and look at that, the player is a class. Well, this is the ES6 version of creating a class like we did, creating a constructor like we did in the live stream. So basically it's just a nicer way to see it, but in let me see. So this is just syntactic sugar, they call it. So basically it's just to make it look nicer, but behind it is basically creating a function, a constructor function, and then okay, let's see. Your YouTube is not receiving enough video. Can you still hear me, guys? Let me know. In the meantime, Carlos, hi, Florin, great live streaming session as you get us a customer too. Thank you. Thank you for watching, and I'm really happy that you enjoyed it. Okay, I hope it still works. Yeah, apparently it looks like it's working. Okay, so yeah, as you can see here in this example, I have a player class which has a constructor. It says the position, the velocity, the size, and then we have the methods: update, switch gravity, show, and then also the block has its own constructor with position and update function and show function. And then we just, inside our main script, we're creating a player by saying a new player of, and then we're using the methods. So yeah, if I manage to finish this game, I'm going to make a tutorial on it, so you'll see how to use OOP. Alright guys, thank you for watching. I hope this was useful for you. I definitely learned something new, which is good. And I'll see you in the next one. I wanted to do it today. I'm not sure. Let me quickly go over functional programming. Might take another hour. Yeah, I'll see. I need to see if I can make it by 6. Yeah, probably. Alright. I'm going to do the next live stream in a couple of minutes, and we'll go over functional programming also, maybe in a faster step. Alright. For those of you who are watching the recording, if you ended up till the end, I congratulate you. If you like this, give it a like, as always, to help the YouTube algorithm to push this to more people. And I'll see you in the next one. Have fun and happy coding!